Hello everyone. In the last lecture, we have discussed about the nucleophilic substitution reaction. We have started the first SN2 reaction. In the last lecture, we have seen the statement of SN2 reaction and kinetics of the reaction. Today, we will start the remaining part of the SN2 reaction. Before we start the mechanism of SN2 reaction, again, I explain the SN2 reaction. SN2 reaction is a nucleophilic substitution reaction where the bond formed and another bond is broken. The other two reacting species are involved in rate determining step. The other two reacting species are involved in a rate determining step of the reaction. The SN2 stands for the substitution nucleophilic bimolecular reaction. Now, this is a SN2 reaction is a one-step reaction. SN2 reaction is one-step reaction. Now, in this reaction, the methyl bromide is primary alkyl halide is used as a reactant. In methyl bromide is reacts with the sodium hydroxide, then the formation of methyl hydroxide. Now this is a mechanism. In this reaction, first draw the structure of the methyl bromide. There are the three hydrogen atoms which is attached to the carbon atom, central carbon atom, and bromine which is attached to the carbon. The bond between the carbon and bromine, this is a polar bond because the bromine is more electronegative than carbon atom. So bromine carries a partial negative charge and carbon carries a partial positive charge. Now in this reaction, OH minus is a nucleophile. There are the two possibilities of hydroxide ion is attack on electron deficient carbon atom is a attack on the electron deficient carbon atom, the front side attack and the back side attack. There are the two possibilities of hydroxide ion is attacks on the electron deficient carbon atom. A front side attack when the nucleophile hydroxide ion is attacked from the same side on the front side, where the nucleophile attacks from the same side where the leaving group is present, where the leaving group is present, resulting in the retention of conjugation, resulting in the retention of conjugation in the product. Now, when the nucleophile hydroxide ion is attacked from the front side, then that time bromine also carries a partial negative charge, hydroxide ion also carries a partial negative charge. So the nucleophile OH minus is repelled by the bromide ions having the fractional negative charge, having the fractional negative charge. Therefore, the nucleophile OH minus approaches the carbon atom from the back side. That means the hydroxide ions group approaches the carbon atom from the back side. That means the back side, the nucleophile is attached from the back side to the electron deficient carbon atom. The side opposite to that of the leaving group, the side which is opposite to that of the leaving group. Then the formation of the carbon hydroxide bond, formation of the carbon hydroxide bond, and the breaking of the carbon bromine bond, and breaking of the carbon bromine bond takes place simultaneously. Takes place simultaneously. Therefore, in the transition state is formed in which the hydroxide and the bromine are loosely attached. The hydroxide and the bromine are loosely attached, and the negative charge is evenly distributed between them. The negative charge is distributed on hydroxide ion and bromide ions. In this state, the molecule has higher energy content. In the transition state, the molecule has highest energy content because they are the five groups are attached to the central carbon atom. They are the five groups which is attached to the central carbon atom. Therefore, the transition state represent the highly unstable arrangement. The transition state is a highly unstable arrangement and very rapidly eliminate the bromide ions. It is a highly unstable transition state. So the bromide ions eliminate rapidly and then to give the product and then to give the product. The other three hydrogen atoms attached to the central carbon atom. There are the three hydrogen atoms which attach to the central carbon atom. This hydrogen can move through the coplanar configuration. These three hydrogen can move through the coplanar configuration in the transition state because due to the backside attacks of the nucleophile to the central carbon atom, due to the backside attack of nucleophile, the product form which is a inversion of configuration. The product is formed with the inversion of configuration. That means the product is formed is a exactly opposite to that of the reactant. The product is formed which is exactly opposite to that of the substrate or reactant. Now the next point is energy profile diagram. Energy profile diagram. It is a graph of the potential energy change taking place during the course of the reaction. It is the graph of the potential energy. It is a graph of the potential energy changes taking place during the course of the reaction. And this plotted against the reaction coordinates. It's a plotting against the reaction coordinates. This is the x-axis. This is the y-axis. Y-axis. This reaction coordinates takes on the x-axis and potential energy along the y-axis. When the start, when the reaction is a start, that means the reactants are methyl bromide and hydroxide ions. Okay, CH3Br plus hydroxide ions. Now this hydroxide ion nucleophile is attached from the back side to the central carbon atoms. Central carbon atoms. So these are the reactants. Then the transition state is formed. The transition state is formed here. Okay, this is a peak. Okay, here this is the energy of activation. EA. EA is a energy of activation. What is the energy of activation? The energy which required. The energy is required to the reactant molecules. the energy is required to the reactant molecules, which goes to the excited state, Okay. Now that energy is called as the energy of activation, EA. Here mention the transition state. Okay, this is a transition state because the SN2 reaction is a one-step reaction. One-step reaction. Bond formation and bond breaking takes place simultaneously. Bond formation and bond breaking takes place simultaneously. This transition state is a very unstable state, and then bromine, the bond breaking between the carbon and bromine immediately, and then to form the product. Methanol, CH3OH plus bromide ion is a displaced here. Okay, Br minus. So this is a reactant. This is the product. First, the energy, potential energy is increases when the reaction takes place. Then this is the intermediate. Okay, the highly unstable state. Then again, the potential energy is decreases. Okay, like that. This is the product formation, and the difference between the two energies, the energy of reactant and energy of the product, that is called as the heat of reaction, the delta H. Delta H is called as the heat of reaction. It is a difference between the potential energy of the reactant and potential energy of the products. This is an energy profile diagram of alkaline hydrolysis of methyl bromide by SN2 mechanism. Okay. Now here the SN2 reaction is complete. Okay, SN2 reaction is complete. Thank you.